So, in last class we talk about single perceptron, and we also said that single perceptron can now solve the very complex problem. Even the data set, even whenever the data sets are not linearly separable, single perceptron cannot solve the problem. So, therefore, we should go with multi-layer perceptron or multi-layer neural network. So, here each one is the perceptron, this one is one perceptron, this one is one, and that one is also a one perceptron. So, whenever we have to solve some complex problem, complex let us say classification problem where data are not linearly separable, classes are not linearly separable, generally we use the multi-layer neural network. So, what is that? More than one hidden layer of computing nodes. So, this is, as you know, this is we say simple computing unit, that is we said simple processing unit, okay, simple processing unit, okay. And then what we did, this is one and this is one and so on. So, now there is something called hidden layer. Hidden means it is hidden from the input as well as the hidden from the output layer. So, in earlier case what happened, we have a direct connection here, we have a direct connection, we have a direct connection, we have a direct connection and so on. But now we do not have direct connection, we have something like that, this structure, okay. So, now these whatever the in between input and output all are hidden. So, therefore, this layer is called hidden layer. In this example, we have only 3 perceptrons who they are located in the hidden layer. So, there may be another layer and there may be another, there may be more, so on. So, these all are basically called the hidden layer. So, more than one hidden layer of the computing node. Every node in the hidden layer operates on activation from the preceding layer and transmit activation forward to the nodes of the next layer. That is, I said ki this layer has one is summation part and another is the activation function, okay. So, another is called activation function, okay, that is I said. And then also referred to as feed forward neural network, this is also can be said at the feed forward neural network, okay. So, multi-layer neural network with at least one hidden layer can solve any type of classification task involving nonlinear decision surface, as I said earlier, okay. So, this is one simple example, as I said the XOR cannot solve the XOR cannot solve the, if the data set single layer perceptron cannot solve the XOR problem. So, instead of one, if you put the multiple one, each one will form a single line. So, let us say this may correspond to this may correspond to one line and this one may correspond to another line, okay. So, and then finally what will happen, that we will get these 2 line and the line above this one may be positive class and then in between is the negative class. So, this is one simplest example. So, that more than one perceptron can solve the complex problem. Now, here just I want your attention in the few thing here. So, that is suppose we have a node n 1 here and we have a node n 2 and then n 3, n 4 and so on and then n 5. Okay. Now, if you carefully see the weight, there is a weight for n 3. How do you write the n 3? So, n 3 if you write it, so this is nothing but some function, that is activation function. So, this is nothing but activation function, and what is there inside? Inside is summation over, what is that? Summation over inputs. So, inputs are coming from node n 1 and n 2 and then weight. So, summation over W 31 into n 1 plus W 32 n 2. So, please note that how these weights are there. So, these 3 indicates actually node number 3. So, this is 3 is coming and then 1 is coming is from previous layer from which node it is coming. So, therefore, 3 1. Similarly, here that weight 3 2 indicates actually it the which layer we are talking about. Say suppose this is the layer 0 layer or input layer. So, this is 1 and this is the second layer. So, here n 3, that is the node n 3. So, 3 and it is coming from the node 2. So, here we are getting. So, from here what is the observable thing? Observable thing is something like that. So, if you talk about the summation at this particular node, what you do, that weight should be kept first, that is that in this what is called is the subscript, and then where from it is coming, that should be next. So, therefore, W 31 N 1 plus W 32 N 2. So, then if I write it here in some form, so I can write W I j and A, what is the A j over the node j, and then this is, let us say we are writing for A I, because why I is something that is for third node I am writing here. So, that should appear first, and j for the all other nodes. So, let us say 1 2 3 1. So, this is n 1 n 2, that is indicating j, and this is what j means actually previous node, that is n 1 n 2 and so on. So, this one actually this notation I will see later in details. Okay. So, this is actually different layers, how much but what work they do. Initially, suppose in a image processing or deep learning neural network are heavily used. So, therefore, if you have a image and then you see is first layer is doing this work, second layer is doing again feature extracting, and third layer is quite okay. So, this is the task at different layer. So, we will continue with the same concept, that is multilayer neural architecture. So, we can say is this is the last layer, that is layer L, previous layer is layer L minus 1, and then arbitrary you can say lower layer L, this is a smaller L, okay. And then first layer is, as I said, it is the layer 0, okay. And now say you have a node, that is ith node, obviously ith node will have the input from the all previous layer. Then how do you write that, what will be the output of a node from a I, okay. So, here we write. So, output, that is it is going out here, okay. This is nothing by a I, that means in the ith node at layer L. So, because this is the L layer, okay. And then what next, including the activation, okay, activation value at node I. Now, what is that function? That function is nothing but the function of z I L. What is z I L? Z I L is nothing but this part, that is z I at the level L is nothing but summation over all the node here, and then this link, this link, this link, this link, and so on node. So, this all the node is written as A j, okay, and that previous layer, that is L minus 1, and then what you have to do, you have to multiply the weight. So, where weight? So, this weight is coming, and this weight, how do you write it? Just few minutes before I said ki you write the weight with respect to A I. So, that is the ith node in the level L we are talking. So, therefore, it should be W, I should come first, and j is some from which node it is coming. So, A W j, and weight at the level associated with layer L. So, that is z, yeah, this one is z, and then obviously, we have a bias term, that is B I L, and its inputs is always 1, as we know. So, that is we get it here, okay. So, there is no confusion about it. So, now what you do it, let me repeat this part. So, we have a node A I, and it is coming from the all previous node. So, then how do you get this activation value? So, activation value can be written as A I at the level L. It should have a activation function, and then as I said ki summation function, you have to add as you have seen earlier. So, that is the function here we wrote it, and then how do you write it? So, we are concerned about the node A I L. So, that is one ith node. So, therefore, you have to write the W I first, and then input is coming from the jth node. So, therefore, you have to write all j, and but it is in previous layer. So, L minus 1, and then you add it, okay. So, now, so here we will spend little time. So, suppose here we have a function. Now, let us we do the derivative of this one, that will be useful later. So, this is sigma, this function is sigmoid function. So, sigmoid function, what will happen for this one? Let us say sigmoid of z I L. So, directly from here, if the function is sigmoid, instead of that, if this is the case, okay, not this one. So, if this is the case here, so what we can write it? So, 1 by 1 plus e to the power minus of z I at level L. Now, I do the derivative of this one. So, how do you how do I do that this derivative of this one? So, what is that? I want to do del A I L delta Z I. Okay. So, what is A I L? A I L is this function. What we do it? We consider t equal to 1 plus e to the power Z I L. Therefore, what we can do it? So, this is the function of del Z I of what 1 by this is t, I said that is 1 by t, but this is the function of Z I. So, therefore, what we do it? We have to do it del with respect to 1 by t and then delta t into delta Z I, that is chain rule we use. So, simply we can compute this one from here. How do you compute it? So, delta t delta z equal to this is constant and then e to the power minus x. So, this will be minus e to the power minus z I L. Now, we have to compute this one. So, this is actually d dx of 1 by x. So, that will be we know 1 by x means minus x to the power n minus 1. So, therefore, 1 by t square and then you multiply with this value, this is also minus e to the power minus z I L. So, therefore, what we can write it? So, we can write, so the minus minus plus, so we can write 1 by t into e to the power minus z I L t, that we can write easily. Now, what you do it? This is what 1 by t, we say you consider this is t. So, that means that is nothing but 1 by t. So, 1 by t is nothing but a I L, right. So, therefore, I replace it value here. So, what we can do it? So, I am concentrating only this this part, yeah. So, what I can do it? I can write 1 by t equal to a I L into this part. So, what is this part? Let me write 1 minus a I L. Okay. So, what will be the value of a I L? So, this is equal to 1 minus what is a I L? A I L is 1 by 1 plus e to the power minus z I L. So, this will give you 1 plus e to the power z I L. So, that means 1 plus e to the power minus z I L minus 1. So, this will cancel out. So, that means this is what e to the power minus z L by t. T is nothing but what is t? T is nothing but this part. So, I can write it here. So, maybe I can write it here e to the power minus z I L t. T is nothing but here, right, where somewhere I wrote t is this one. So, 1 plus e to the power minus z I L. So, this is nothing but what 1 minus a I L. So, therefore, this value will come a I L, that is a I L into this value, that is 1 minus a I L. Okay. So, this is derivative part, we did it here. Okay. So, now what you do it? We will say the how why I did it here, okay. But we need to remember this part. Okay. So, now problem is we said that we have the multi-layer neural network and so on, many things we said, but problem is how to set the weights. Okay. So, in single layer perceptron we have seen that we can easily set the weight using, that is W I j old equal to W I j new plus delta into weight function into x I j, that is I said in the previous class. But it is really difficult here because we have the internal node here, we have the internal node and we know the ultimate output is loss, that is only we know, we do not know what will be the value here and then what is expected value and what is computed value, what is the expected value for this node, that we do not know. So, therefore, we cannot use the same technique for multi-layer perceptron for what is called is setting the parameters W I j. Okay. So, therefore, we use the something called gradient descent. Okay. So, gradient descent, first before knowing that gradient descent is what we have to do, as I said ki for y k for a sample or y for expected what is called is predicted value, generally what we do, write it y I j into a I, okay, a j at level L minus 1 over summation summation and then b I L, that is we got it here. Then this is the function of w I j and b j, because we will get the value. So, earlier what we learned ki predicted value, that is y bar equal to w 1 x 1 plus w 2 x 2 plus say b. That means, here we know the value for whenever we have the training sample or whenever we have test data set, we know the value x 1 x 2, but we do not know the value of w and b. So, therefore, so this is the error. So, error is written as summation over all the training sample loss of y k and y k bar. Y k is the actual value and y k hat is the computed value. So, now if we consider the loss function is a squared loss. So, that means, whatever the error is getting, you make it square. So, that is differences whatever we are getting, we will make it square. So, that is loss here. Now, what is the purpose? Purpose is that we have to identify the right value of w b for which this error is minimum. For that, if the function is quadratic function, there is a method is called gradient descent to know the value of the parameters, that is w I j value we can easily compute. Here there are two parameters w I j and b. So, we can compute using something called gradient descent. So, in gradient descent values are updated as follows. So, what is the old value? Arbitrarily you choose some values for the all variables and then you gradually change the value using these two formula. What is that? So, essentially these two are same, but it is for the it looks different because of the variable is different. So, let us say w I j is a variable, obviously as I said earlier. So, we will be like that. What is that? Old value negative of lambda, lambda is nothing but learning parameter of the gradient with respect to the variable w I j, and similarly with respect to the other variable w b I. What I do it? I will tell you why this formulation is right with one simple example here. Okay. So, what I do it just before gradient descent, I will give you just 5 minutes what is called is some example that will tell you why this should work. Okay. I am not giving you how it is coming, I will say if we work why this is right, that I will tell you. Okay. So, two are different thing as you must understand here. So, what I do it, what is that? We have a loss function here, okay, and then we have a loss function is nothing but a, as you see, is a quadratic function. What you do for simplicity, let us say we have a single variable, instead of two variable we have a single variable, and that is y equal to so x square. So, that means I can write f of x equal to x square. So, any value of x, this function value always will be positive, x can be positive to negative. Now, what we do it, let us say what is the objective? I should get a value x whenever the w is minimum. Similarly, I should get the value of w and b, I should get a value of x where w is minimum. Here I should get the values of w and b whenever the error is minimum. So, objective remains same. Now, in the simplified version, what I do it, let us try to see what happens. So, what is y equal to x plot? So, y equal to x square plot will be something like that, not like that. So, it will be, so if value is, so let us say value of x is 1, so then this will be 1, value of x is 2, so this will be 4. Similarly, if you put the minus 1, it does not change here. So, if it is minus 1 here, if it is plus 2, so minus 2, so that also will be 4. Okay. Now, what is objective? I have to find the value of x where the function value is minimum. For that one, we will be using the gradient descent for this example. I will show you why the gradient descent will work for this type of quadratic function. How do you do it? Let us say what you do it for you take any arbitrary value of x and we find the gradient at this point. So, let us say we have the value x equal to 2 and we find the gradient at this point. So, gradient of this point will be something like that. Now, what is that formula is said? Formula says for x 1. So, x this new value will be x old value negative alpha delta y del x. So, this is nothing but this line, and then what it says, whatever this value it is coming on that direction you go on the downhill, because this value is negative, and then you multiply it with some parameter that is lambda. That means, whenever you go down, you go little down, not very high, do not go very fast way. So, that is something you go little here. Now, again therefore, value will be whatever the value it was 2. So, now it will decrease. So, let us say it will be decreased by 1.198 or 1.98. Say let us say x, and this is coming 0.1, and then what is that? X square is twice x. So, x is 2. So, this will be 4. So, this will be 4. Okay. So, then x was 2 minus 0.4. So, this will be 1.6. So, now you go down 1.6 will be somewhere here. So, now again you do same thing, and then essentially what we do it, if you see any slope on the right side, it will be positive slope. So, whenever always you will get the positive slope, always you will get the positive slope. If the slope is positive, then you have to go down. So, then it will be reduce the value. Now, you imagine a situation, let us say the value of x is minus 2, you started with the value of x equal to minus 2. So, let us say minus 2 is somewhere here. Now, what you do it, again you draw the slope here, and you know this slope is essentially the negative slope. This is a straight line, and this slope is essentially negative. Now, if you see the formula here, what is that formula? Formula remains same here. So, this is lambda. So, this value is itself a negative because minus 2 old value. So, this value will be minus 2, because what is the objective? If the value is here, that should be actually it should go down to 0. If it is here plus 2, it should go to down to 0. What I wanted to convey is that system automatically should choose the where is the down direction. So, that negative will help you here, because this is already the slope is already negative. So, this value will come negative, okay, and this value is negative, and this value is what 0.1 something, some negative value, okay, let us say minus 4. So, this minus it will be plus. So, therefore, minus 2 plus 0.4. So, it will be minus 1.6. So, then it will be going down here, again it will come down here, and it will come down here, and then eventually it will reach the point. So, therefore, the formula whatever earlier I said it here. So, it is satisfying for any quadratic function. Okay. So, that is the message I want to give you. Okay. So, here we say, so this is now the our main formula is here. Okay. So, this is two main formula that we have to look into. So, it is the same thing, what we do it, only we will see this formula how it can be used in the next. Okay. So, here what we have to do, we have to compute this part. This one also we have seen. Now, what is this one? This is the value at the last part of the node, that is the last node, that is layer L, capital L. So, this is the value. Now, what we have to do? We have to compute this value. So, to compute this value, what do we do it? Say we will use the chain rule. So, here we go chain rule. So, chain rule says if you want to compute, so what we want to compute? We want to compute this value. This is henceforth we will write, leave it. So, only we will write the loss. So, we want to compute this one del loss by del wij. So, using chain rule, what we can do? Del loss by day loss with respect to del AIL. AL is a function of ZL. So, ZI. So, therefore, del AI ZL ZIL, and again ZIL what you do it is a function of W and B. So, again because we have to compare with respect to loss with respect to this one. So, therefore, first is this one. Now, having said that, what do we need to do? We have to compute this value, we have to compute this value, we have to compute this value, and then multiply. For simplicity, what we do it? We assume this value is delta at the level node I and the level L, and this value if you remember we just now we computed this value, just derivative we did it. So, that is A I L into 1 minus A I L, you can verify it. Now, what you have to do? You have to compute this part, is it okay? So, how do you compute this one? This is very simple. What do you know? Z I L equal to summation over W I J L A J L 1 plus B I L. Then what you do it? We have to compute this one, delta Z I delta W I J with L, right. So, now you have a summation term here, that means we have the W I J with L, J if you change 1, 2, 3 whatever, this will also change, I is fixed. So, therefore, if you take the derivative all will be the constant. So, therefore, this all value will be 0, only this part will remain same, and then if you take the derivative with respect to W I J L, you will get from here A J L 1 and this part is constant. So, therefore, directly we can put it here A J L 1. Okay. So, that is here we have A J A I. So, we got from here this one, earlier we computed this part, okay. Okay. And then this part we said we assume it. Now, what is the task? We have to compute this part. Okay. So, once we understand this part, then I think we will finish this class. Okay. Now, we move to this one. What is that? Del loss with respect to del A I L. Okay. So, to understand this one, what is this? We have to compute loss with respect to any intermediate nodes. So, here we go. What is that? We have the structure like this is last node and then this is one node, previous node, and then there would be a node here. Okay. So, this is something like that. So, now this is the last node L. First we compute the loss with respect to the A I is nothing is there because this is only one with respect to last node. So, therefore, we compute del loss with respect to last node. So, that is what is the loss? Just few minutes before we studied y by y gap, y cap. Y cap is what? Last node A L. So, therefore, we put A L with respect to A L. Now, you derivative it. So, if you derive it here, so that will come here 2 and then A L with respect to A L should be minus 1. So, therefore, you can change it 2 into A L minus y. Okay. Now, question is I computed loss with respect to this node A L, but what happened for intermediate node? So, ideally what we will do it, we while computing with respect to this node we will take the help of the previous node. So, now I computed this part. So, to compute the loss with respect to this node, what we do it? We will take help of the previous node. So, here we go, we use the same chain rule. What is that? So, let us say this is node, this is last node A L, previous node is L minus 1. So, what I write it? This is L smaller and this one I write the next node is L plus 1 and this previous node is L minus 1, that is all. So, I am computing with respect to this node. So, what we have to do? We have to compute del loss with respect to node del I with respect to node L, where L is nothing but the previous node of the last node. For here what you do? We will use the chain rule. What is that chain rule? Again we use del loss with respect to del A I L plus 1. That means, while computing this one I will use what is the loss with respect to the previous node, that is this one. Again chain rule we will apply del A I L plus with respect to del Z and with L plus 1. Then with respect to A I we have to compute, again chain rule we use delta A I L into delta Z I L, this is L plus 1, this is L. So, now I have to compute this part here. Okay. So, what you do it? This one already we have computed, right, because in earlier case if you go back here. So, we computed with what, we computed with delta A I L with respect to Z I L. So, if you put A L plus 1, so it will be the same thing here. So, the second part will remain the same thing. So, that is the, here we are writing here, this is the second part. And then what is the delta loss with A I L plus 1? So, this is L plus 1 is what, last node. So, that we have computed here, we can directly put it here. That is nothing but with respect to the delta with respect to L. So, that is delta I L plus 1. Next, what is the next over is this part. What is that? I have to compute delta A I L plus 1 with respect to delta Z I L. So, what is A L I? Okay. So, here what I do it here, A I L plus 1. So, this is nothing but function of Z I L plus 1. Okay. So, to compute this one, we have to, what we have to do it. So, it is something like that. Okay. What is that? Z I L plus 1 with respect to, so Z I L plus 1 is summation over, what is that summation over Z I L A with respect to A I. So, therefore, W I j, it is attached to its L plus 1 level into A j, and what will be there here. So, if you go back the formula here, let me go back here. So, that is whatever the value A I L or Z I L we say, it should be L minus 1. So, whatever the value here, it should be minus 1. So, therefore, what, where I, yeah, A j will be L plus, so it will be L. Now, we compute with respect to this one, right, this is nothing but A I L. So, if you compute this value, as I said earlier, this is a term, obviously there is B I L plus 1, but this is a constant, and this all sum will be the constant, it will be 0, only this part will be there with respect to, okay, with respect to, this is, okay, this is with respect to delta A I. So, this is with respect to delta with respect to A I L, is it okay? Z I plus 1. Okay. So, this is actually Z I L plus 1. So, now if you take this one with respect to L, only this part will be there. Okay. So, this will be W I j L plus 1. So, that is coming here. Okay. Okay, I stop here.